For me to get velocity, I'll say velocity is the integral of what we have here is 5 minus 3t. This is dt, because you are integrating by with respect to t. Now you realize that if we integrate this one, v will therefore be, this is 5t minus 3 over 2 t squared. Because we have 1 plus 1 here, so 2 divided everything divided by 2 plus c, where c is the constant. And how do we get this constant? We are told that the initial velocity was 20 meters per second. It means at the starting point, at point 0, the velocity was 20 meters per second. That means when t was 0, because at the fixed point t, when it was starting the journey, t was 0. So time t is 0 and v is 20. So we are going to say if t is 0 and v is 20, then we can be able to find our c here, meaning we are going to say v is 20 equals to 5t, and our t is 0 minus 3 over 2, and our t is 0 squared plus c. So this will give us, all this will be 0, so I'll say 20 equals to c. So we can say now the velocity function, full velocity, complete velocity function here will be, the expression here is this, so it will be 5t minus 3 over 2t squared plus 20. This is the velocity function. So you see we have used integration to be able to determine the velocity function from acceleration function. And then here they're telling us to find the velocity at t equals to 3 seconds. So it means this case, for us to get velocity at t, 3 seconds, we just take 3 here, we substitute in the velocity function. We say v here will be 5 into t is 3 minus 3 over 2 into t is 3 squared plus 20 there. So v will be, if I do that, it will be 5 times 3 minus 3 over 2 is 1.5 into 3 squared plus 20. What I get there is 21.5. So I'll get 21.5 meters per second. That is the velocity of this particular particle after 3 seconds. The question B is find the distance covered when the particle comes to rest. Find the distance covered when the particle comes to rest. When a particle comes to rest, or when particle is at rest, v is 0. That's what we know. So first, I want to get the distance, because the distance is displacement function. So it means that for me to get S, I will say, is the integral of v, and our v is here. So I'll say v, which is 5t minus 3 over 2t squared plus 20 dt. This is going to give us the displacement. So I'll say now S now will be, this is 5 over 2 t squared minus 3 over 6, because I'll have 1 plus that one there, t cubed, plus this will be 20t plus c. So this is S equals, this is just 5 over 2 t squared. This is a half t cubed plus 20t plus c. So for us to get the distance here that is covered, the initial distance or initial one, we need to assume the initial distance is 0, The reason why we have to assume that is 0, and this c here should be our initial distance, because if you are to sketch a curve of this function, this will be the s-intercept, meaning the initial distance before the journey is started. But if you are moving across a straight line, from a straight line here, at this particular point on this line before you start the journey, 0 meters is covered. So it means that we have to assume this one here, c is 0. Now is c 0, if we assume c 0, then we have the s function, the displacement function, which is 5 over 2 t squared minus a half t cubed plus 20 t. But remember, the question did not ask us that. The question wanted the distance covered when the particle comes to rest. Now when a particle comes to rest, v equals to 0. So we have to come back to the v function here and assume that v, which is equals to 5t minus 3 over 2 t squared plus 20 will be 0, because we know at rest velocity is 0. So if this is that way, what we are going to do is that this is negative 3. Let me assume I'm bringing everything here. So I remove that, so I'm bringing everything here. We'll get 3 over 2 t squared minus, if I'm taking them there, minus 5t minus 20 equals to 0. So let's multiply by 2 to remove, so this will just be 3. So it means everything is just okay there. So if you are now solving this one, let me use quadratic formula, which is t is negative b plus or minus square root of negative b squared minus 4ac, everything divided by 2a. So b is equal to negative b, which is just 10, positive 10, plus b squared is negative 10 squared minus 4 times a is 3 times negative 40 times minus 40 times 2 times 1. So here we'll say that t will be 10 plus or minus,
what is a? 3 or 1?
a is 3, sorry. A here is 3, so we have to put 3. So that is okay. So 10 squared minus 4 times 3 times negative 40, we get 580 over 6. So square root of 580, that will be 10 plus or minus 24.083 over 6. So we can say t equals to 10 plus 24.083 divided by 6, you get 5.6805 seconds, or t equals to 10 minus 24.083 divided by 6 is negative 2.347 seconds. Now you realize that time cannot be negative, so we are actually going to assume that value we are not going to use. We are going to assume that this object comes to rest, or this particle comes to rest after time is equals to 5.6805 seconds. But we know that our displacement function is here, so let's get distance. Distance now will be s equals to 5 over 2 t squared, and t squared is, t is 5.6805 squared minus a half into 5.6805 cubed plus 20 into 5.6805. So S will be 5 over 2 is 2.5, 2.5 in bracket, 5.6805 squared minus 0.5 into 5.6805 cubed plus 20 into 5.6805. That is giving us 102.63 meters. This is the distance that is covered when the particle finally comes to rest. So let's go to example 2. So viewers, this is example 2, and now we are going to at least use the concept we have learned in the example 1, and also we are going to bring in the concept of trying to calculate the distance between 2 points. Like in this case, the distance on the 5th second or between the 1st and the 3rd second. Now, we know that the velocity of a particle is given to us V is 4 meters per second. Given that S is 5 meters when T is 2 seconds, we can be able to determine if this is V function, so we can say this question A solution for A, V equals to 4 meters. So from this one, this is the velocity function, we can be able to get the displacement function, which is the integral of this, which is 4. For here, we know we have to, with respect to T. So if I integrate this one, I will get 4t squared, 4t is just 40 plus c. So 4c plus c is our s. So if our s is 4t plus c, because we have to integrate this, we know that 4 is the same as 4t power 0. If you add 1, then divide by 0 plus 1, then plus c, obviously. So this is 40 over 1, which is just 40. Now we know that we have been given some items here. S is equals to 5 when t is 2. So we can substitute here to get c. S is 5 when t is 2. So I'll get, say, 4 into 2 plus c. This is 5 equals to 8 plus c. So c here will be equal to negative 3, because I'll take 5, bring here, 5 minus 8 is negative 3. So I can therefore substitute and say S is 4t minus 3. This is the displacement function, and that's what we were told to find. So after we get that, the second question B, and in this case B Roman 1, we are told to find the distance moved by the particle during the 5th second. Now we know that if we are going to do this to get this one, we are going to get the differential already. We have got here 4t minus 3. So we are going to have that 5 as the upper limit and 4 as the lower limit. So we are going to subtract the distance covered up to the 4th second minus the distance covered up to the 5th second. So the distance covered after the during the 5th second is, after the 5th second is 4 into 5 here minus 3 minus we have here 4 into 4 minus 3. So this one will give us, this is 20 minus 3 minus 16 minus 3. This will be 17 minus, this is 13, this is 13. 17 minus 14 is 4 meters. So we can say that the distance covered on the 5th second is 4 meters. Why do we substitute, why do we bring in this 4 here when we are told the 5th second? We know that we have the full distance up to the 5th second and another one up to the 4th second. So if you subtract the total distance here minus this distance here, we will get the distance here. That's what we are trying to do. So finally, let's look at question Roman 2 quickly. And Roman 2, they are saying the distance moved by the particle between first and third second. So again, we just know that that distance is going to be written this way, 4t minus 3. This is 3, this is 1. So we'll say 4 into 3. 4 into 3, yes, minus 3 minus 4 into 1 minus 3. This is 12 minus 3 minus 4 minus what is 1. So what we are going to do here is to get, this is 9 minus 1, which is 8 meters. So between first and third second, we cover 8 meters as the distance. So viewers, you have done a few examples, only 2 examples, but I think they are sufficient enough to be able to guide you on what you need to get. So viewers, practice these questions, and if you have any problem that you need us to help you with, please don't hesitate to contact us in the comment section. Put your name and also the area where you think we need to do more clarification for you.